Hey guys, so in class we've been recently working on rectangular prisms and triangular prisms, and more specifically finding the surface area of these objects. So here in my hands I have a McCafe box, which is a rectangular prism. Okay, it's a rectangular shape, and it's a 3D object. It is a rectangular prism. The things we know about a rectangular prism: it has a front, it has a right side, a left side, a bottom, a back, and a top. Now, we know the front and the back are the same. They're going to have the same area. They're the same shape, right? Our sides are the same, and our top and our bottom are the same. Now, you can't have situations where the front, the bottom, the back, and the top are all the same, but that would have to mean that this would be a square, which in this case it looks very squarish, but it's not exactly a square. So, the reason our measurements to start are really important. So when I measure across the bottom here, okay, it's just under 15 centimeters. For the purpose of this video, we're going to call it 15 centimeters. Then when I come and measure the top, going from the bottom to the top, it is 10 centimeters. And measuring from the front to the back is 9 centimeters. So, if we imagine here, we said this was 15, this was 10, and this was 9. So for this face, we have the 15 and we have the 10, because it's 15 times 10 going across. This is 10, 10, 10, 10, and this is 15, 15, 15, 15. So it's 15 times 10. Now we know 15 times 10, okay, anything times 10, you take the number, add a 0 to it, so 15 times 10 is 150. If we know the front's 150, the back is also going to be 150. So, we know this is 150. We're going to write this down on a sheet of paper here, that the front is a little blurry, but this is just for us to remember. The front and the back are both 150 centimeters squared, because it's it's a rectangle, but we're talking about squared units, little squares. So it's centimeters in little centimeter by centimeter, so they're centimeters squared, so 150 centimeters squared. So the other side we're going to have to figure out is the right side and the left side of the box, and the top and the bottom. So the right side, we already said that this here was 10. So we know that this here as well is also 10. It's the exact same, right? It's the exact same length. It's the same thing, right? This is all flat and even, so this is the same. This is 10. And we also measured earlier that this is 9. So again, we have the same principle, right? A number times 10 is just itself with a 0 added at the end. So 10 times 9 is 90. We know that anyways. So the right side, which means it's also the left side, is going to have an area of 90 centimeters squared. Okay? Now, the last one I have left is my bottom or my top. Now, we already said, okay, right here, this of our top is 15. We already measured this, right? This whole thing going this direction is 15. If it goes from left side to right side, we measured that, it's 15. And this is really the same thing as this was here, okay, this right here, which was 9. Sorry. No, this was 9. Yep, sorry. Yeah, I even got myself mixed up there. So this was our 9 going across. So that means that this here is 9, and this is 15. So we have 15 going across this way, and 9 going across this way. So 15 times 9, well, we know 15 times 10 is 150. So if I just take 15 away from that, that's 135. And you're allowed to use a calculator for this. I'm just doing it a little quick. So we get 135 centimeters squared for the top and the bottom. That is really blurry. I'm just going to zoom back out. So now what I'm going to do is I'm just going to add these all up. I'm going to grab a whiteboard real quick so it's a little clearer. But at this point, it's just basic addition, which we've done much practice on this year. We're good at adding up these large numbers. We've done the Pythagorean theorem. So we have 150, and we have it twice, because if we have it once, we have to have it twice. We have 90 centimeters for our right side, and we had 90 centimeters for our left side. We had 135 for the top and 135 for the bottom. Now if I add these all up, 0 plus 0 plus 0 plus 0 is 0. 5 and 5 is 10. Put my 0 down and carry my 1. 5 plus 5 is 10. Plus 1 is 11. Plus 9 is 20. Plus 9 is 29. Plus 3 is 32. Plus 3 is 35. 5 down, carry my 3. 3 plus 1 is 4, plus 1 is 5, plus 1 is 6, plus 1 is 7. 750. Again, in this unit, you're allowed to use a calculator for this. It's okay. It's no big deal. So, this means our surface area for our entire rectangular prism is 750 centimeters squared. Now, there is a little bit of a trick to this as well. So, right off the bat, we calculated our 3 measurements. I like to pick one corner. I normally pick the bottom right. If you measure from the bottom right corner in all directions, so 15, it was 15, it was 10, and it was 9. If you take all those numbers and multiply one by another, okay, you're going to get all of your sides. That might sound a little confusing, but I'll show you. So, this one, so our 3 measurements were 15, 10, and 9. So here, this was 15 by 10. So we have 15 times 10, which gave us 150. On this side, okay, we had 10 times 9. So there's 10 times 9. And on this one, we had 15 times 9. 15 times 9. So for a rectangular prism, you can see if you find your 3 measurements starting from one corner and measure those 3 sides, you're going to end up having just a combination, 3 combinations of the possible multiplication. So you have to have 15 times 10 and 15 times 9. You have to have 10 times 15 and 10 times 9, and 9 times 10 and 9 times 15. So all the numbers just multiplied by each other. And that'll give you the 3 sides. And then if you put it there twice, so then you just got to think, well, if this is the front, then like we said, there's going to be a back of 15 times 10, a 10 by 9, and a 15 by 9. That's just a little trick. If you find that a little bit confusing, just stick with the other way that we did it, where we just measured all the sides. But it makes it a little bit more, it makes it a little quicker if you do understand that route. Okay, now we're talking about nets as well. Net being what if we took this cube and sorry, not a cube, this is a rectangular prism. If we took this rectangular prism and turned it into something flat, so we could see the surface area. So I'm just going to actually take my scissors and cut this so that it becomes a net. There we go. So this here is our net. And this makes it even easier. So now what we can do is we can just take our ruler, okay, and measure each side individually, and it's a little less confusing. And what I like to do is just write on it what it was. So again, here's my 15, okay, and you can see that it's 15. Now this is a little bit slanted because it's not a perfect box because it's the packing job, but we're going to imagine that it's perfectly straight. So this would be, so this is 15 all the way going down. This is all 15. So this length here is 15, 15, 15. Here we have our 9. No, I measured that wrong. This was our 10. Yeah, sorry. I knew I had to make a mistake. That didn't make sense for a second there. Yeah, this was the 10. I measured it wrong. I put it in the wrong spot. That makes way more sense. So here's our 10. Then this measurement here is our 9. Yeah. There we go. This one is also a 9. Okay. This one's going to be the same, because if you look here, I can flip it back, turn it back into the box, right? There's our front and our back. But I could also measure it. Here's our 15, and this is our 10. And then here, well, like I said earlier, right, it has to be a combination of all of them. So we have 15 and 10 and 15 and 10, 15 and 9, 15 and 9. So these ones are going to have to be our 9s and our 10s. So we know here, well, this is 10, so this has to be 10 going across. This is 10, and this has to be 10, and this length here has to be 10. And then we can see that this is 9. If you fold it up, it actually makes sense, because if you fold it up, it turns back into our box. Right? So there it is back as our box. So if this side is 9, this side here also has to be 9, because they join together. 9, 9, and 9, and 9. I mean, I can mark it all the way around. I don't have to. I just need a couple. And then same thing here. If this is 10 and 9, this one's also 10 and 9. And we do the same thing. 10 times 15 is 150. Right? 9 times 15 is 135. 9 times 10 is 90. Right? And you get the point. And basically, we would just do the exact same thing. We would take this net with all of the individual areas. So here's the area for just this space. Here's the area for just this space. And add it all up, and we're going to get our 750 again.